The engine that comes out of a car at 80,000 miles didn't have to come out. 9 times out of 10, when I'm pulling a motor that should have had another 200,000 miles left in it, I already know what killed it before I've even cracked the valve cover. And one of these 17 habits is something your dad probably told you was fine. He was wrong. Most people spend $30,000–$40,000 on a car and then run it into the ground with habits that cost nothing to change. That's the part nobody talks about. I'm Jack, 30 years a mechanic, and I run my own shop in Ohio, and I've watched more engines die from these 17 habits than from any accident or manufacturer defect combined. Habit 17. You let the gas tank run to empty. This one's everywhere. People do it on purpose. They think they're being efficient, stretching the fill-up as long as possible, and what they're actually doing is running a fuel pump without any cooling. Here's what most drivers don't know. The fuel pump in a modern vehicle sits inside the gas tank, and it uses the gasoline surrounding it to stay cool. When you run the tank down to the last eighth, that pump is spinning hard with almost nothing to pull from, and it's generating heat it can't shed. Do that twice a week for 5 years, and you're not saving money, you're building toward a fuel pump failure that'll leave you stranded on the highway and cost you somewhere between $400 and $900 in parts and labor, depending on the vehicle. The pump itself is usually between $150 and $350. Labor to drop the tank and replace it runs another 2 to 4 hours at shop rates. On a newer truck or SUV, you can easily crack $1,000 all in. And here's what makes it worse. The failure rarely comes with much warning. One day the car starts fine, the next morning it cranks and nothing happens. That's because fuel pumps don't typically degrade gradually, they work until they don't. The heat damage accumulates invisibly over years, then the pump just quits. I've had people come in completely surprised. They say the car was running perfect yesterday, and when I ask how often they let it run low on fuel, they look at me like the question doesn't make sense. It makes a lot of sense. The last 2 fuel pump replacements I did in the shop were both vehicles under 90,000 miles. Both owners were in the habit of running to empty. Fix this one today and it costs you nothing. Fill up when you hit a quarter tank. That pump stays cooled, stays lubricated, and you stay moving. You don't need a special product. You don't need a mechanic. You just need to stop at the gas station a few miles earlier than you used to. And the next habit on this list is one that actually has a price tag attached to ignoring it. And that price tag is higher than most people expect. Quick word before we keep going. What you just heard, that kind of habit, that kind of specific practical knowledge, that's what I put in my book at jackcartermanual.com. Everything in there. The intervals, the habits, the actual procedures, written for someone who's never popped a hood. I won't keep interrupting the video with it. If you want it, it's there. Habit 16. You ignore the coolant. Most people check their oil. Not enough of them check their coolant, and fewer still actually change it. Coolant doesn't last forever. People hear lifetime coolant on certain vehicles and take it literally. What the engineers mean is something closer to long life. What drivers hear is never touch it. Those are 2 very different things, and the gap between them is a cracked head gasket. Here's the mechanism. Coolant has 2 jobs. It carries heat away from the engine, and it prevents corrosion inside the cooling system. The first job is obvious. The second one is what kills engines quietly. Fresh coolant contains additives that coat the inside of your water pump, your radiator, your heater core, and the passages inside the engine block itself. Those additives break down over time. Once they're gone, the coolant becomes slightly acidic, and that acid eats away at aluminum components from the inside. Modern engines are built with a lot of aluminum. Cylinder heads, intake manifolds, water pump housings, all of it vulnerable to coolant that's been in the system 3 years past its service life. The failure mode isn't dramatic at first. You might see the temperature gauge creep up a little higher than normal on a hot day. The heater might not get quite as warm. Then one morning the car overheats. You pull over, and when my shop gets it, I find a water pump that's eaten through from the inside, or worse, a head gasket that's been compromised because the engine got too hot one too many times. Head gasket replacement is not cheap. On a 4-cylinder, you're looking at $1,200 to $2,000. On a V6 or V8, that number can double. I've replaced head gaskets on vehicles that had fewer than 100,000 miles on them because the owner never touched the coolant. The fix is straightforward. Check your owner's manual for the coolant service interval. It's typically every 30 to 50,000 miles on most vehicles, or every 3 to 5 years, whichever comes first. Get the right type of coolant for your specific vehicle. This matters more than people realize. GM vehicles typically take Dexcool. Most imports take a different formulation entirely. Using the wrong type can cause the additives to react with each other and create a sludge that plugs the cooling passages, and then you've got a different kind of problem. When in doubt, do a full flush. Drain the system, run distilled water through it, drain again, and fill with the correct coolant at the correct concentration, typically 50-50 with distilled water. While you're at it, squeeze the radiator hoses. They should feel firm but pliable. A hose that feels hard and rigid, or one that feels soft and mushy, or one that has any cracking on the outside is a hose that's going to fail. Replacing a hose is $20 in parts and 30 minutes of your time. Having it burst on the highway is a tow bill, a possible engine damage bill, and a very bad afternoon. Habit 15. You never change the cabin air filter. This one won't destroy your engine, but it'll destroy your HVAC system, your air quality, and eventually your blower motor. And blower motor replacement runs $200 to $400 once labor is included. The cabin air filter sits in the airflow path for your heater and air conditioning. It catches dust, pollen, leaves, debris, and everything else the outside air carries into your dash. Most manufacturers recommend replacing it every 15,000 to 25,000 miles. Most people have never replaced one at all. When that filter clogs, a couple of things happen. First, the blower motor works harder to push air through a restricted filter. That motor is running under more load than it was designed to handle hour after hour, season after season, and electric motors don't like being overworked. They run hotter. The brushes wear faster. Eventually, the motor fails, and by then the filter is so clogged that debris may have gotten past it and fouled the evaporator core. Cleaning an evaporator core means pulling the entire dashboard. That job at a shop can run $1,000 or more, all to fix a problem that started with a $12 filter. Second, the air quality inside your car gets genuinely bad. A heavily loaded cabin filter grows mold. Every time you run the AC or the heater, you're blowing mold spores into the cabin. People think their car just smells musty. The car smells musty because they're breathing through a filter that should have been replaced 2 years and 30,000 miles ago. Replacing a cabin air filter is usually a 5-minute job. On most vehicles, it's behind the glove box. You open the glove box, press in the sides to let it drop down, and the filter slides right out. Takes longer to drive to the parts store than it does to install. Budget $15 to $20 for the filter, do it once a year or every 15,000 miles, and your blower motor runs cooler, your air smells clean, and you're not paying $400 because you skipped a $12 part. Habit 14. You skip the differential fluid. Front-wheel drive cars don't have a traditional rear differential, but they have a transaxle that does the same job. Rear-wheel drive and four-wheel drive vehicles have 1 or 2 rear differentials, and on four-wheel drive trucks and SUVs, there's also a transfer case. All of these share one thing in common. They contain gears running under load at high temperatures, and they need clean fluid to survive. Most of them never get it. The differential takes the rotation from the drive shaft and redirects it 90 degrees to turn the rear wheels. The gears inside are hypoid gears. They mesh at an offset, which means extreme pressure at the contact points. The gear oil inside a differential has to handle that pressure, and it has to handle the heat those loaded gears generate. Over time, that oil breaks down. Metal particles from normal gear wear accumulate in the fluid. When the fluid is old and contaminated, the gears are running in metal-laden sludge instead of clean lubricant, and the wear rate accelerates. Most manufacturer intervals for differential fluid are every 30 to 60,000 miles. A lot of trucks and four-wheel drive SUVs that come through my shop have never had it done, and the owners have no idea it exists as a service item. I've cracked open differentials on trucks with 150,000 miles and original fluid. The fluid looks like chocolate pudding, thick with metal particles. At that point, the gears are already scarred. The damage is done. A differential replacement, not a rebuild or replacement, on a half-ton truck runs anywhere from $800 to $1,500 for parts alone. Add labor and you're looking at well over $2,000. A complete differential service. Drain the old fluid, inspect the cover gasket, refill with the correct specification gear oil, costs between $70 and $150. Do it every 45,000 miles, and that differential will likely outlast the rest of the truck. If you have a four-wheel drive vehicle, do the transfer case fluid at the same time. Same logic, same interval, same cheap fix versus an expensive repair. The transfer case contains its own gears and its own fluid, and it gets the same neglect. Habit 13. You leave the parking brake alone. People who drive automatics, especially in flat states, never use the parking brake. They put the car in park and walk away. The problem is that the parking brake cables and the parking brake shoes or caliper mechanism are designed to be used. When they sit unused for months or years at a stretch, the cables corrode and seize. The rear brake hardware on vehicles with drum-style parking brakes can rust and fuse. Here's what that costs you. When the parking brake seizes, you might not notice until you try to sell the car and the pre-purchase inspection flags it, or until your rear brake job suddenly includes seized hardware that doubles the time and the bill. On vehicles where the parking brake uses a small drum inside the rear rotor, which is most modern rear disc vehicles, a seized or corroded parking brake mechanism often means replacing the entire rear rotor assembly and servicing the internal hardware. That adds $100 to $200 to a rear brake job you wouldn't have needed otherwise. The parking brake also exists to protect your transmission. When you park on any grade without setting the parking brake, the full weight of the vehicle loads against the parking pawl in the transmission, a small metal pin that locks the output shaft. That pawl isn't meant to hold the vehicle's weight, it's meant to be a backup. Do that for 10 years on a hilly driveway, and you're adding stress to a transmission component that costs several $1,000s to fix if it breaks. Use the parking brake every time you park, not occasionally, every time. It takes 1 second and it keeps every cable, every shoe, every mechanism from seizing up from disuse. If your parking brake hasn't been used in years, have a shop check it before you start using it. A seized cable can cause the rear brakes to drag if it releases improperly. But once it's confirmed working, use it. It's free insurance for your transmission and your rear brake hardware. Habit 12. You ignore the serpentine belt. One belt. That's all that stands between your alternator, your power steering pump, your air conditioning compressor, and your water pump working, and all of them stopping. On most modern vehicles, one serpentine belt drives every one of those accessories. When it goes, they all go, simultaneously, on the side of the road with no warning if you haven't been watching it. Serpentine belts are made of rubber compounds reinforced with internal cords. The rubber side, the V-grooves that grip the pulleys, wears down gradually. The cords can develop internal cracks that don't show on the surface. A belt that looks okay to a quick glance can be within 1,000 miles of failure. The service interval is typically 60 to 100,000 miles, but heat, oil contamination, and hard usage can shorten that significantly. A belt that's run in extreme heat, say a truck that does a lot of towing in summer, might need replacement at 50,000 miles, even if it doesn't look it. When a serpentine belt snaps, first you lose power steering, then the battery light comes on because the alternator stopped charging. The temperature gauge starts climbing because the water pump stopped moving coolant. If you don't get the car stopped quickly, you can overheat the engine in minutes. A serpentine belt that breaks and gets pulled into the cooling fan can damage the radiator, the fan shroud, and the wiring in that area of the engine bay. What would have been a $60 belt and 45 minutes of labor becomes a tow bill and a repair estimate that starts at $300 and climbs from there. Belt replacement is straightforward. The part is cheap, $40 to $80 for most applications. Ask your shop to inspect it anytime the hood is open for another service. Look for cracking on the underside, glazing on the ribbed surface, fraying on the edges, or any section that looks or feels stiffer than the rest. If the belt is past 75,000 miles and you don't know its history, replace it. The peace of mind is worth more than the cost of the belt. Habit 11. You don't check the tire pressure and you think the TPMS light is good enough. Tire pressure monitoring systems became mandatory on U.S. vehicles in 2008. They are a good thing. They are also widely misunderstood. The TPMS light comes on when a tire is approximately 25% below the recommended pressure. That means by the time the light is telling you something is wrong, you may be running at 22 or 23 psi on a tire that should be at 32. You've been doing damage at 30 psi for a while before that light ever lit up. Underinflated tires wear on the outside edges while the center tread stays thick. That uneven wear pattern means you're replacing tires earlier than you should. But the wear cost is almost the secondary issue. Underinflated tires run hot. The sidewall flexes more than it should with every rotation, and that flex generates heat in the rubber and the internal cords. Heat is what kills tires. At highway speeds, a tire that is significantly underinflated can heat to the point of sidewall failure. The tire doesn't just go flat, it blows out. At 70 miles an hour, a blowout on a front tire especially can mean losing control of the vehicle. A set of 4 tires on a mid-size sedan runs $600 to $1,000. A set on a 3/4-ton truck can run $1,200 to $1,800. Running your tires underinflated by 5 psi reduces their lifespan by roughly 15 to 20%. On a $1,000 set of tires, that's $150 to $200 of rubber you burn through early, just because you didn't check the air. And the fuel economy hit is real too. Every psi below optimal adds about 0.1% to your rolling resistance, which adds to your fuel consumption. Over 50,000 miles, that's a noticeable number at the pump. Get a digital tire gauge. They're $5. Check pressure once a month, cold, meaning before you've driven more than a mile. The correct pressure for your vehicle is on the sticker inside the driver's door jamb, not on the tire sidewall. The number on the sidewall is the maximum, not the recommended. Cold check, door jamb number, once a month. That's the habit. That right there is one habit out of 100 in my book. Every one of them is laid out with exact intervals and procedures, even if you've never touched a car before. 101 habits to get your car past 500,000 miles, all of it in my book at jackcartermanual.com. It costs less than an hour of shop labor. All right, back to the countdown. Habit 10. You run the wrong grade of motor oil. This is not about brand. The brand debates online are mostly noise. What matters is viscosity and specification, the numbers and letters on the label, and using what the manufacturer engineered the engine to run. Modern engines have tighter internal tolerances than engines from 20 or 30 years ago. Variable valve timing systems, oil pressure-controlled phasers, timing chain tensioners that rely on oil pressure to function, all of these depend on the correct viscosity oil reaching them in the correct amount of time from a cold start. If your engine calls for 5W20 and you're running 10W30 because it was on sale, you're running an oil that flows more slowly when cold. That extra thickness means the oil takes longer to reach every bearing, every phaser, every cam surface after startup. Cold starts are when most engine wear happens, the first 30 seconds before oil pressure is fully established. You're extending that vulnerable window with every cold start. Over 100,000 miles of cold starts, that adds up. The other side of this is people running thicker oil and high-mileage engines thinking it'll stop leaks or reduce consumption. There is some logic there, but it has limits. A 10W30 in an engine that calls for 5W20 might reduce minor seepage at a gasket, but it can also starve the oil pressure-dependent systems that modern engines rely on. I've seen timing chain tensioners fail early on engines that were consistently run with the wrong viscosity. Timing chain replacement on a V6 or V8 can run from $800 to over $2,000, depending on how far the damage went. The specification on the label, look for something like APISN Plus or Dexos 1 Gen 2 or whatever your manufacturer calls for, tells you the oil meets the additive package requirements for your engine. Cheap oil that meets spec is better than expensive oil that doesn't. Use the grade in your owner's manual. If the manual says 5W20 synthetic, use 5W20 synthetic. Don't improvise. Habit 9. You ignore the transmission fluid. Transmission fluid is the single most overlooked fluid in a vehicle. People know oil gets changed. Most people have at least a vague sense that coolant exists. Transmission fluid? Most drivers have never thought about it once. And the transmission is one of the most expensive components in the vehicle to replace. Automatic transmission fluid has to do several things at once: lubricate the internal clutch packs and bands, carry hydraulic pressure to shift the transmission, cool the transmission through an internal heat exchanger, and keep everything clean. It's under heat stress every time the transmission cycles through gears, and it degrades. The friction modifiers that allow the clutch packs to grab smoothly break down. The fluid darkens and thins. Once the friction modifiers are gone, the clutches don't grab the way they should. You get slipping, a momentary surge in RPM when the transmission should be holding a gear. You get shuddering at highway speeds. Eventually you get no third gear, or no reverse, or a transmission that limp homes you to the shop in low gear only. Transmission replacement on a half-ton truck runs between $3,000 and $5,000. A factory rebuild with updated parts can be in that same range. A fluid service, drain, fill, new filter if accessible, runs $100 to $200. Most manufacturers call for fluid changes at 30 to 60,000 miles in severe service. A lot of people have never done one at 100,000 miles. I had a customer bring in a Chevy Silverado last spring, 112,000 miles, never touched the transmission fluid. The fluid that came out was black and smelled burnt. We serviced it, which it desperately needed, but the clutch packs were already worn and the truck had developed a perceptible shift flare going into third gear. The damage was already accumulating. Had that fluid been changed at 60,000 miles and again at 100,000, that truck might have run the transmission to 200,000 without issue. If your transmission fluid is dark brown or black, or if it smells burnt, service it immediately. If it's been more than 60,000 miles since the last change, or you don't know when the last change was, service it. If the shop says the fluid looks fine and you just drove 100,000 miles on factory fill, get a second opinion or change it anyway. The cost of the service is a rounding error compared to the cost of a transmission. Habit 8. You cool down wrong after hard driving. This one applies specifically if you tow, haul, drive in hilly terrain, or run your engine hard in any way before shutting it off. The turbocharger, if your vehicle has one. The exhaust manifold, the cylinder head. All of these components reach temperatures well above what they'll be at idle, and cooling down matters. Here's where it gets specific. Turbochargers. On turbocharged vehicles, the turbo bearings are lubricated by engine oil that circulates through the center section. Under boost, the turbo can spin at well over 100,000 RPM, and the center bearing is running on a thin film of oil at very high temperature. When you shut off the engine after hard driving, the oil pump stops, but the turbo is still hot, very hot. The oil remaining in the turbo housing can cook against the hot metal and form carbon deposits on the bearing shaft. Over time, those deposits restrict oil flow, starve the bearing, and the turbo fails. A turbocharger replacement on a pickup truck runs from $800 to $2,000 for the turbo unit alone. Labor on top of that can add another $400 to $800. This is a failure that happens in stages. First, the turbo starts to make a slight whine that wasn't there before. Then it may start smoking. Then it fails outright. The fix is simple. After any hard driving, towing highway runs at high speed, sustained grades, idle the engine for 2 to 3 minutes before shutting it off. The oil keeps flowing, the bearing stays lubricated while the heat dissipates, and the turbo lives. On most modern turbocharged vehicles, there's also an electric water pump that keeps coolant circulating after shutdown. Make sure that system is working correctly if your vehicle has it. And change your oil on time, because degraded oil forms carbon deposits far more readily than fresh oil. If you don't have a turbo, this habit still matters for brake cooling after heavy towing or mountain driving. Don't shut the engine off immediately after descending a long grade under heavy braking. Let things cool. Give the rotors and pads a chance to stabilize before the vehicle sits. Habit 7. You delay replacing brake fluid. Brake fluid is hygroscopic. It absorbs moisture from the air. All of it does this by design because a system with distributed moisture is safer than one where moisture pockets somewhere and boils. But as the moisture content rises, the boiling point of the fluid drops. Fresh DOT3 fluid boils at around 400 degrees Fahrenheit. Fluid that's been in the system for 2 or 3 years may have absorbed enough moisture to drop that boiling point below 300 degrees. When brake fluid boils, on a long downhill, in heavy stop and go, or on a hot track, you get vapor in the brake lines. Vapor compresses. Brake pedal goes to the floor. That's brake fade from fluid degradation, and it happens fast when it happens at the wrong moment. Most manufacturers recommend replacing brake fluid every 2 to 3 years or every 30,000 miles. Very few people do it. The service itself costs $40 to $100 at a shop. You can test your fluid's moisture content with an inexpensive tester available at any auto parts store. It reads in seconds and tells you if the fluid is still good or needs replacing. The other failure mode is internal corrosion. Moisture-laden fluid corrodes brake calipers, wheel cylinders on drum brake setups, and ABS modulator components from the inside. Caliper replacement runs $100 to $300 per corner, plus labor. ABS modulators can run several hundred to over $1,000. All of that corrodes slowly and silently, while old brake fluid sits in the system year after year. Replace the brake fluid. It's one of the cheapest maintenance items on the car and one of the most skipped. If you don't know when yours was last changed, change it. Habit 6. You wash the car but skip the undercarriage. This matters most in states that salt the roads in winter. Ohio is one of them. Salt brine gets thrown up into the underside of the vehicle with every mile you drive on salted roads. It coats the frame, the brake lines, the fuel lines, the suspension components, and the exhaust system. It sits there and works. Slowly, methodically, it oxidizes bare metal and attacks protective coatings. The brake lines on a car are usually steel, sometimes with a coating, running the length of the vehicle from the master cylinder to each corner. They last almost indefinitely in dry climates. In salt belt states, I've seen brake lines corrode through on vehicles with fewer than 100,000 miles. A brake line that develops a pinhole leak can fail gradually. You notice the pedal going a little soft, the fluid level drops slowly. Or it can fail suddenly, and then you have no brakes. Complete brake line replacement on a vehicle with extensive corrosion can run from $500 to well over $1,000 depending on how much has to be replaced and how seized the fittings are. Fuel lines corrode the same way, so does the frame itself on older trucks. I've had farm trucks come in where the frame had rotted to the point that the vehicle wasn't safe to drive. That's an extreme case, but it doesn't happen overnight. It happens over 15 years of salted roads and a washing routine that never included the underside. Run the undercarriage wash at the car wash or spray it yourself with a garden hose if you have access underneath. After every significant salting event, not once in the spring when the damage is already done. A few minutes of cold water knocking salt off the underside is worth more than a full detail that ignores everything below the rocker panels. Habit 5. You ignore oil consumption between changes. Some engines consume oil. This is known, documented, and varies by make and model. A quart every 3,000 miles on a high-mileage engine isn't automatically alarming. A quart every 1,000 miles on a modern engine with 40,000 miles is a problem. The critical mistake isn't the consumption itself, it's not checking. People get their oil changed. Get back in the car and don't open the hood again until the next service interval. On an engine that's burning or leaking a quart every 1,500 miles, that means the engine can be running on 2 quarts of oil by the time the oil life monitor says it's time to change. An engine running low on oil runs hot. The remaining oil is under more stress, covering fewer surfaces and breaking down faster. Bearing clearances tighten as oil pressure drops. Cam lobes run dry. Low oil pressure is one of the fastest ways to destroy an engine. If you run an engine dry of oil, even briefly, you can score the bearings, scour the cylinder walls, and wipe the cam lobes flat. That's a full engine rebuild or replacement, which runs anywhere from $3,500 for a remanufactured engine on a 4-cylinder to $10,000 or more on a diesel or large V8, not including labor. Check the oil every 1,000 miles, or every other fill-up if you drive a lot. Takes 30 seconds when the engine is cold. Wipe the dipstick, reinsert, pull it clean, read the level. If it's low, add the correct oil to bring it to the full mark. If it's consistently losing more than a quart every 2,000 miles, find out why. It might be a valve cover gasket that's leaking. It might be a PCV valve that's stuck and causing the engine to pull oil through the intake. It might be worn piston rings. Some of those are cheap fixes. Some are expensive, but knowing is always better than finding out when the engine knocks. Habit 4. You skip the air filter and think it doesn't matter. The engine air filter is one of the most frequently upsold items at quick lube shops. They pull it out, hold it under a fluorescent light, and tell you it needs to be replaced immediately, and the customer says yes because the filter is right there and it looks dirty. That's the upsell shop story. Here's the real story. A legitimately clogged air filter does real damage, and a lot of people skip it entirely because they've been burned by the upsell so many times they think it's always a scam. The air filter keeps abrasive particles out of the engine. Sand, dust, road grit, pollen, all of it gets pulled in with the intake air, and the filter catches it before it reaches the cylinders. An engine cylinder's bore is machined to very tight tolerances. When abrasive particles get past a failed or missing filter, they act like lapping compound between the piston rings and the cylinder wall. They grind away the surface that's supposed to hold a tight seal. You get increased blow-by, increased oil consumption, decreased compression, and eventually a cylinder that's out of spec and burning oil. A paper panel filter for most vehicles costs $15 to $25 and takes about 3 minutes to replace. The interval is roughly 15 to 30,000 miles, depending on your environment. Dusty conditions shorten it significantly. If you drive on dirt roads regularly, check it every 10,000 miles. Hold it up to light. If you can't see light through the pleats, it's time. If it's collapsed, torn, or has any gap at the seams where it seats in the housing, replace it immediately. A filter that's bypassing unfiltered air is worse than no filter at all, because a missing filter at least makes obvious something is wrong. The next habit is one that I've seen kill engines that were otherwise being maintained perfectly, and it's one of the most misunderstood items in automotive maintenance. Habit 3. You never flush the power steering fluid. Power steering fluid lives in a system that includes a pump, high-pressure hoses, a rack and pinion unit or steering gear, and a reservoir. The fluid transfers hydraulic pressure to help you turn the wheel. Over time, it degrades, picks up moisture, and becomes acidic. The seals inside the power steering pump and the rack are made of rubber compounds. Old acidic fluid attacks those seals slowly. The result is seeping, then leaking, then failure. A power steering pump replacement runs $200 to $500. A rack and pinion replacement, which is what you're looking at when the rack seals fail and the unit starts leaking, runs from $500 to over $1,500 plus 2 to 3 hours of labor at shop rates. Alignment after rack replacement runs another $80 to $150 because you've disturbed the steering geometry. All of that can be delayed significantly by flushing the power steering fluid every 50 to 75,000 miles. The service is simple. Use a turkey baster to remove as much old fluid from the reservoir as possible. Fill with fresh fluid, run the steering lock to lock a few times to circulate it, draw it out again, Repeat until what comes out is clean. Or have a shop do a full pressure flush. The whole thing costs $30 to $60 in fluid. There are vehicles in my shop right now with 200,000 miles on the original rack because the fluid was changed. One thing to know, if your vehicle has electric power steering, which most vehicles built after 2010 have, there's no fluid to change. The system is fully electric. Skip this one if that's your setup. But if you have hydraulic power steering, this is a service that almost nobody does and almost everybody should. Have it too. You never check or replace the spark plugs on schedule. Misfires are expensive. An engine misfire means one or more cylinders are not firing correctly. The air-fuel mixture is igniting late, incompletely, or not at all. The cylinder that's misfiring is still pumping air and fuel, and that unburned fuel gets pushed into the exhaust stream and into the catalytic converter. The catalytic converter then tries to oxidize that raw fuel. This generates heat inside the converter far beyond what it was designed to handle. A single sustained misfire can destroy a catalytic converter in a matter of hours of driving. A catalytic converter on a modern vehicle runs from $400 for an aftermarket unit to well over $2,000 for a factory unit on certain imports and trucks. If the catalytic converter is damaged, you also have to find and fix the root cause of the misfire, or you'll destroy the new one too. In my shop, misfire jobs that started as a simple ignition diagnosis have turned into $1,000 jobs more times than I can count, just because the car was driven with a misfire rather than brought in immediately. Worn spark plugs are the most common cause of misfires. Modern iridium and platinum plugs are specified to go 60 to 100,000 miles. Extended life plugs in some applications go 120,000 miles. The problem is that the gap at the tip of the plug, the distance the spark has to jump, wears wider as the plug ages. A larger gap requires more voltage. The ignition coil has to work harder. Eventually the coil fails trying to fire a worn plug, and now you've replaced a $30 set of plugs with a $200 coil, and you still have to do the plugs. Replace the plugs at the manufacturer's interval. On a 4-cylinder engine, it's a 30-minute job. On a V6 or V8 where the rear bank is buried, it's more work, but it's still far cheaper than a catalytic converter and a coil. Use the correct plug for your application. Iridium to iridium, platinum to platinum. Don't cheap out on the ignition side. It's not the place to save $20. Habit 1. You treat every oil change interval the same, regardless of how you drive. This is the one that surprises people. Manufacturers publish oil change intervals: 5,000 miles, 7,500 miles, 10,000 miles under normal conditions. Some extended life synthetic intervals go up to 15,000 miles. People read those numbers and treat them as facts rather than as averages based on assumed conditions. The conditions are the key word. Manufacturer service intervals define severe service as a separate category, and it includes frequent short trips under 5 miles, extended idling, towing or hauling near maximum capacity, driving in dusty or extreme temperature conditions, and stop-and-go city driving. In severe service, most manufacturers cut the oil change interval roughly in half. A lot of people driving in severe service conditions don't know they're in severe service. They think they're just driving to work. Here's why short trips are the real killer. When you start a cold engine and drive 2 miles to work, the engine warms up to operating temperature right around the time you arrive. The combustion process produces water vapor as a byproduct. In a fully warmed engine, that water vapor evaporates and gets expelled through the PCV system. On a short trip, the engine never gets fully hot. That moisture accumulates in the oil, and over time you develop sludge. Engine sludge, and this is a real documented failure mode on several high-profile engines, including certain Toyota V6s and several Chrysler products from the early 2000s, coats the oil passages, blocks the oil pickup screen, and starves the engine of lubrication. The only fix for advanced sludge is engine removal and cleaning or outright replacement. I bought my truck new in 1996. It now has over 780,000 miles on the original engine. I change the oil every 4 to 5,000 miles because that truck works. It tows, it hauls, it idles for long stretches in cold Ohio winters. I treat it as severe service because it is severe service. The oil that comes out is never black. It's dark amber, which is where oil should be at change time. If your oil is coming out black and gritty, you're either waiting too long or you're in severe service and treating it like normal service. Assess your actual driving conditions. If more than half your trips are under 10 miles, if you tow, if you idle a lot, use the severe service interval. If you're genuinely doing long highway miles in moderate weather, the extended interval might be appropriate. The point is to make that call based on what your engine is actually experiencing, not based on what sounds convenient. Every one of these 17 habits is documented, verifiable, and observable in any busy independent shop. The ones that killed the most engines on my lift weren't catastrophic decisions. They were small, repeated habits that added up over 100,000 miles until the engine couldn't compensate anymore. The difference between a car that reaches 200,000 miles and a car that reaches 700,000 miles isn't luck, and it isn't the brand. It's the habits that kept my truck alive past 780,000 miles, and then some, are in my book at jackcartermanual.com. Go grab it. What's the longest any of your vehicles ever lasted, and what do you think made the difference? Drop it in the comments. I read them. I'm Jack. Stay safe out there, and I'll see you in the next one.